All right, this is problem 13, this guy here. The volume of two similar rectangular solids are 1,064 centimeters cubed. What is the ratio of their, oops, I did it again, lateral areas is the rest of that problem. So we have the volumes. And I guess what I'm going to do is I'm going to say 1,000 over 64 is equal to the scale factor cubed, because it's a volume, right? So it's a distance times a distance times a distance. And so we want to cube root both of those things, both the numerator and the denominator, and that's going to be 10 over 4 equals the scale factor, and that's 5 over 2. So the scale factor is 5 over 2. What is the ratio of their lateral areas? And when we go to area, we're going to get a scale factor squared, because we're multiplying two lengths together, and that's going to be 25 over 4. So that's that one. 14 is a cone and a cylinder. Each have a radius of 3 and a height of 4. Find the ratio of their volumes and of their lateral areas. Well, the volume of a cylinder is the area of the base times the height. The volume of a cone is 1/3 area of the base times the height. So the volume of the cylinder compared to the volume of the cone is 3:1. And the ratio of their lateral areas, that's the first, this 3:1 for the ratio of the volumes is equal to the scale factor cubed. So the ratio of the sides, do I want to say that? No. The ratio of their areas, well, maybe I have to be a little more careful about this than I thought I was going to be. Let's do that. I think it's just going to be, well, let's be careful. So we have a cone, which is going to be the volume. Well, let's do this. Let's do the volume of the cone versus the of the cylinder versus the volume of the area, and that's going to be pi r squared h over 1/3 pi r squared h. Then there and r and h are the same for both of those in this case because it's 3 and 4. I mean, we could just, I mean, the easy way to do it is just to plug in 3 and 4 for the area. Oh, it's going to be more complicated because the ratio of the areas, the area of the top guy is 2 times the area of the base plus 2 pi r h. We've talked about that before. That is, unraveling the side to turn it into a rectangle, where the length of this rectangle is 2 pi r. It's all that distance. And then the height of it is h. And then the area of this guy is both the lateral area, which is pi r l, L being the slant area, and plus we got to do a pi r squared. So that's 2. No. That's pi RL. And we should probably think of how to write L in terms of R and H. So pi RL is just a formula that we have for the surface area for the lateral area of a cone. And then we have plus pi r squared. And L is equal to, let's see if we can follow this. This is equal to the radius squared plus the height squared. And then if we want to write it all at once, that's square rooted. So that's equal to pi, there's no pi in there. That is equal to that's equal to sorry, Monica. That is equal to the height squared plus the radius squared, square rooted, to give us this hypotenuse squared. Well, we're going to go ahead and plug in those numbers. So that's 3 squared, 3 squared plus 4 squared, that's equal to 5. And the radius is 3. So I'm going to go ahead and start filling in the numbers. That's 2 times, this top is 2 times the area of the base, which is 9 pi. So that's 18 pi plus 2 times pi times 3 times 4. And that is 24 pi. Is that right? Because that's 2 times 3 times 4, which is 24 pi, over pi times r times L. R and L are 3 and 5, so that's 15 pi, plus 9 pi, and that's 42 pi over 24 pi. It's really the ratio of the areas, and that's 42 pi over 24 pi. And I can take a 6 out of the top and 6 out of the bottom, and that's 7 over 4. So that's just a miscellaneous result. Okay, let's see if we can fit another one on here. That's going to be, I think my video will keep going. That's going to be 15. Find the volume of a sphere with an area of 9 pi. So the area of a sphere is 4 pi r squared, and that's equal to 9 pi. And if I do the math, I can divide by pi, I can divide by 9, I can divide by 4, I can get r squared equals 9 over 4, that's 2.25, r equals 1.5, and then if that's the area, then the volume equals 4/3 pi r cubed. I'm going to call 3 over 5, 1.5, I'm going to call that 3 over 2. And when I cube 3 over 2, that's going to be 27 over 8. I'm going to write that 27 over 8 before I write the pi. And that's going to be, this is a 9, and that's a 1/2. And so that's 9 halves, pi. All right, Monica, that's that.